Welcome everyone to the fourth and last webinar in our spring series on interprofessional collaborative practice, program evaluation. This webinar and the three previous are all based on the National Center's Practical Guide number 5, Incorporating IPCP Teamwork Assessment into Program Evaluation. Welcome back to all who have joined us on previous webinars, and we are delighted to welcome those who are dialing in for the first time. Please stay tuned for information at the end of the webinar about our Nexus Summit 2018 and the Practical Guide Evaluation Short Course, which continues to take a deeper dive into measurement and assessment. The National Center is a jointly accredited provider of interprofessional continuing education credits for the healthcare team. This statement describes the nature of this presentation and the 1 hour of continuing education credit available to those who selected that option at the point of registration. If you have any questions about continuing education, please let us know in the chat box, and we will answer your questions at the close of the webinar. This slide states that our presenter, Doug Archibald, does not have a conflict of interest with this presentation today. My name is Jennifer Kurtz, and I'm the Deputy Director of the National Center. It's my pleasure to be on this webinar today and to introduce you to one of our co-authors of Practical Guide number 5 and today's presenter, Doug Archibald. Doug is an assistant professor in the Department of Family Medicine at the University of Ottawa. He has a PhD in education from the University of Ottawa and a Master's in Arts in Education from the Ontario Institute for Studies in Education. His research interests are in medical education, interprofessional education, research methodology, and e-learning. Doug is the Program for Research and Innovation in Medical Education, otherwise known as PRIME, lead, and works to support research, development, and evaluation of projects designed to enhance undergraduate and postgraduate education and faculty development. His current research is exploring how electronic consultations can inform continuing professional development for primary care providers. We are so pleased to have Doug presenting today from Canada, and we thank him for his work with his co-authors on Practical Guide number 5. With that, I'll pass the ball over to Doug.
Thanks, Jennifer. Today, we'll explore some of the content discussed in Guide number 5. Our previous guides focused on IPCP teamwork and the assessment of individual learners, teams, or environments. Today, we'll build on that foundation, but shift our focus to the programs that you're all designing to change the collaborative practices of individuals, teams, and organizations. The guide has 3 main parts, as shown on this slide. Today, we're going to focus on part 2, components of an evaluation plan, particularly some considerations for design decisions. I hope by the end of our hour, you will first be able to outline a quantitative approach for a given evaluation purpose and question. And second, identify ways to ensure high-quality data when using certain measures. And third, you'll be able to differentiate between descriptive and inferential methods of analysis. Today, we'll spend about 15 minutes looking at the quantitative approaches to evaluation that include measures such as rating scales and questionnaires and when to use them. We'll spend about another 15 minutes looking at considerations to ensure the data you're using and you're collecting are of high quality. And finally, I'll take about 15 minutes to walk you through some common statistical techniques. Obviously, in just an hour, this is not enough time to go into detail on any of these measures or analyses discussed, but hopefully you'll find this to be a good starting point. And the remaining time of the webinar is reserved for your questions. I thought it prudent to begin today's webinar sorting out this question, evaluation or research. If you have attended the 3 previous webinars or you've read Chapter 5, then you probably know the answer to this question. But I'm bringing this question up because both evaluation and research use the same methods for collecting and analyzing data. The difference, of course, is your intent. If you're asking questions that are important to your stakeholders, funders, planners, and learners, then you're doing evaluation. In research, the intent is to contribute to the broader scientific literature. In program evaluation, the questions you ask tend to be about your local program. They're stakeholder generated rather than from curiosity or theory. The outcomes of program evaluation will most likely include recommendations for your stakeholders and may or may not be published. In research, your findings or results are to be transferable or generalizable to a wider population, as the intent is to contribute to the scientific literature, and it should be published. Now, regardless of whether you're doing evaluation or research, the designs and methods are more or less the same, and we'll discuss these in some detail a little bit later. As I mentioned before, the questions you are asking in evaluation are stakeholder-driven. Is the program effective? Is it working as intended, etc.? On this slide, I've written out the basic assumptions of quantitative research. As mentioned previously, in evaluation we use the same methods as research, so our analyses are similar. And depending on the questions and design, we may well be making predictions and hypotheses. If you're using quantitative measures in your evaluation, then you could probably say your methods are evaluator neutral. As I mentioned before, however, the intent of the evaluation is local and specific, so not necessarily generalizable and replicable. And unless you have an experimental design, which I would say is very difficult to do in an evaluation, you're probably not able to claim a cause and effect relationship. Types of evaluation questions. This is your starting point and will determine the next steps. Will you be using qualitative measures to help you answer your question, as was discussed in the previous webinar? Or will you be using quantitative measures? Or perhaps you'll be doing a mix of both. For quantitative questions, there are essentially 2 purposes. Questions can involve describing data, arguably the most common and practical type of question. How many students? The percentage of students that graduate, average score, mean score, etc. However, some questions can lend themselves to measures that enable more sophisticated questions that can explore effects. Prior interprofessional collaborative experience may explain a certain amount of variance in perceived stress, for example. In the first webinar, the roles of logic models and evaluations were discussed. Logic models are important tools for conducting theory-driven evaluations. They are graphic representations that display the purpose of the program and its content, resources, activities, outputs, outcomes. Logic models are very helpful in determining not only questions to ask, but the best means for capturing data, your measures. As we noted in Chapter 5, the Kirkpatrick hierarchy is one of the most commonly applied evaluation approaches. Most evaluations tend to focus on the bottom levels of the hierarchy, mainly because the questions we ask and the measures we use can only capture evidence at these levels. To evaluate behavioral change and outcome, it takes more time, resources, and sophisticated measures. For example, to truly measure the impact of a program on changing provider behavior or even societal change, we may need to look at healthcare administrative data over a period of many years to note any changes in patterns. There are many means to collect data or measures. In the last webinar, you probably talked about using interviews, focus groups, field notes or observations, and even open-ended survey questions as measures to collect qualitative evidence. Listed here are means that collect numerical data, and these can be of continuous variables, meaning that we measure to as many decimal places as the instrument will allow us, discrete variables, those variables that can be counted, nominal or categorical variables, such as marital status or sex, ordinal variables, such as pain ratings, for example. We can also have interval variables and ratio variables. Now, they can be self-reported measures or objective measures. And in any evaluation, you may have a mix of both. On this slide, we can see that there are some common quantitative research designs, which of course can be applied to evaluation. I would say that most evaluations are descriptive in nature. Also, there's a growing popularity in combining qualitative and quantitative methods, or mixed methods. Psychometrics may be involved if you're developing a measuring instrument for programs to use as well as your own. Observational designs can be used but take careful planning, and I would suggest consulting a researcher and or a statistician in the planning stage of your evaluation. Experimental designs, they'll provide the highest forms of objective evidence, but do take time and resources. Again, consult with a statistician is advised. Consultation with a statistician is advised. Okay, let's look at some of these designs. The RCT. Randomized controlled trials have long been considered the gold standard in quantitative research. They occur in controlled conditions and require a manipulated or an independent variable and a dependent variable. Individuals in the evaluation are randomized, and comparisons can be made between individuals who receive the intervention and those that do not. The post-test design. This is the first RCT design. The intervention group receives the intervention, or the manipulated variable, and the control does not. In other words, the independent variable is not manipulated. It's the way it was always done, or the way it was done before. At the end of the intervention, there's some sort of post-measure given. There are variations of this design, for example, a step wedge design, where all participants will receive the intervention, but it's staggered. Just like the post-test design is the pre-test, post-test design, except here there's a pre-test given at baseline for participants prior to the intervention, and then the post-test is given. The quasi-experimental design, it's just like the RCT, except there is no randomization, and there may or may not be a control group. However, there's still manipulation of an independent variable. And it's more realistic for evaluations, as often it's difficult for the evaluator to randomize. Most programs can't isolate the treatment or the manipulated variable because we tend to work in holistic, interrelated environments with both planned curricula and even some unplanned extracurricular activity as well. Therefore, it's difficult to standardize the experience for any particular group. Furthermore, interprofessional education programs tend to roll out an intervention to all students across schools, making it difficult to find a comparison group. So, I think RCTs, tend to be more feasible in clinical situations and settings. right, where IPCPT models or other variables can be manipulated across sites without contamination. In observational studies, participants are natural groups of people, not selected samples, as we saw in the previous slides. There's exclusion and inclusion criteria, and essentially we can look at observational studies in terms of three categories. The difference between a cohort and case-controlled studies is the direction of the inquiry. In cohort studies, the inquiry starts with the predictor or independent variable. In other words, an exposure or characteristic that is different between the cohorts or groups. Whereas in a case control study, the inquiry starts with the criterion or dependent variable. In other words, an outcome that is different between groups. With the associational or correlational study, the evaluator or investigator is not interested in the cohort or group differences, but rather the relationship amongst the variables. Often in interprofessional education setting, there are numerous predictor variables of interest. Thus, multivariate analysis, which we'll talk about a little bit later, such as multiple regression, are used to explore these relationships. A type of associational study is the cross-sectional study, all right, which is a snapshot, okay, certain variables in a variety of people, and then you investigate the extent to which they're associated. Descriptive studies. These are probably the most common, this is probably the most common design, often used to describe or evaluate a new initiative, and they tend to be local. Psychometrics. As I mentioned before, this design is the most appropriate for instrument development. Typically deal with measurement and measurement instruments. The assessment is very well researched. Is very well researched in the area of healthcare education. Right? Therefore, there have been a lot of psychometric studies in this area. Right? With psychometrics, you're concerned with reliability. All right, that's reproducibility and internal consistency, although this does fall under validity. Okay, that's a very quick overview, okay, of research designs, and it concludes the first section of the webinar. I'm going to pause now for about 30 seconds. So if you have any questions, please submit them. Alternatively, you can wait until the end of the webinar. Okay, no questions? Let's move on. Okay, next, how to ensure high-quality quantitative data measures. Remember, garbage in, garbage out. The quality of your responses from any measure is only as good as the measure itself. I love Dilbert. So, if you're using a rating scale or objective test, hopefully it's undergone some form of reliability and validity testing. Same goes for surveys or questionnaires, which may very well be the most common measure for gathering quantitative evaluation data. You may have a choice to use an off-the-shelf survey or one that you create yourself. Here are some pros and cons to both. Regarding homemade surveys, the most problematic issue is poorly designed questions. For example, you may be asking 2 questions in one, what we call double-barreled questions, and respondents don't know how to answer. For example, were there clear and detailed instructions given to begin the program? Well, a respondent may think, well, the instructions were clear, but they weren't very detailed. Confusing response scales. Sometimes a Likert scale is used when a simple yes or no response will do. Or when rating something, there are no anchors or there are no explanations as to what those anchors are. In other words, just rate the session from 1 to 5. Unclear instructions are another problem. And probably the best guarantee for learners not to complete another survey for your next evaluation is if you don't follow up with them with the survey results. Before sending your survey out, get colleagues to review it and test it amongst a small group of learners first. In other words, do a short think aloud to ensure that users of your survey are answering the questions as you intended them to answer. The issue with off-the-shelf surveys is that although they may have a higher degree of validity and reliability, there may be a monetary cost to using them. Furthermore, there may not be specific enough, or they may not be specific enough for your particular context. This brings us to some general considerations for your evaluations, particularly in relation to the quality of the measures that you're using. First, all right, I want to acknowledge that these come from an evaluation chapter in the Understanding Medical Education text. And I find that they're very applicable for IPC evaluations too. First, timelines. Make sure you plan your data collection and analysis in enough time before the program decision-making is made. Second, generalizability. It's hard to publish site-specific results. You need to make a case for how your study will actually contribute to the literature, and be sure to describe your context in detail so that readers can determine if the evaluation is applicable to their context. Standard of acceptability. Remember, evaluation is about making judgments. What will be considered successful in your context? Next, measure only what you can. Choose the path of least resistance. Perhaps you can only capture one source of data. Next, keep your surveys short. No extraneous information. High response rates are important for controlling bias. Reliability, as I mentioned before. If your survey is not reliable, then drawing conclusions from your results could have implications. And the last is really self-explanatory. Don't just focus on what went well when you're reporting data, or what didn't go well. Okay, that is sort of a little bit of information on the second section of the webinar. I'm now going to pause for a few seconds so you can submit any questions about quality, ensuring the quality of your measures. Otherwise, again, you can wait until the end of the webinar. Okay. It doesn't seem to be any questions, so we'll now move along. All right, now we move to the third section, which is statistical analysis. Now, some of the slides from this section I borrowed from a former colleague of mine at the University of Ottawa, Melissa Duffy. She's now a professor at the University of South Carolina. Now, this analysis section is truly just an overview. If you're not consulting a statistician, then I recommend taking more training than this webinar provides. It helps to use statistical software when analyzing any of your quantitative data. Software will do the calculations for you, provided you enter the correct instructions. Many software packages will convert your existing spreadsheets into compatible files for the software. Now, essentially, as I said before, there are two types of statistics, descriptive and inferential. Descriptive statistics describe the data you have, measures of central tendency, mean, median, mode, frequencies, percentages, etc. Inferential statistics allow us, however, to explore relationships amongst the variables or to compare groups. Well, any type of analysis, quantitative or qualitative, is the process of aggregating, organizing, or describing data in order to understand patterns or relationships in the data, summarize evidence in a meaningful, interpretable, and systematic way. Quantitative analysis allows us to answer the how many or how much type of questions. And sometimes we can test hypotheses and produce findings that are generalizable. Generally, with qualitative analysis, the time-consuming part of the evaluation or research is in the analysis, coding and interpreting. With quantitative analysis, running calculations and the interpretation is fairly quick. The time-consuming part is actually up front, crafting the research questions, deciding on the methods and the type of statistical analysis. Also, cleaning the data once it's collected. You may also want to use software, but make sure that it's appropriate for what you want to do. Also, beware of the assumptions of analysis. Many statistical analyses have assumptions that you do not want to violate. For example, in some parametric tests, an assumption is that your data are normally distributed. If your data are not, you may want to consider using a non-parametric alternative. Cleaning the data is important. It's a very important step. And you need to decide, for example, how you're going to deal with outliers and missing data. In qualitative data, you're probably really interested in the outliers. In quantitative analysis, the outliers may actually prove to be problematic. And finally, reporting results. There are proper and accepted forms for presenting your results. Fortunately, there are many resources available to you in print and online to help you with this. So, as I mentioned before, there's two forms of statistical analysis: the descriptive, which involves summarizing your data sample, mentioned before, central tendency, and also variability. Right? This is the variance in standard deviation. You've probably seen this in many reports. Right? You could have a mean score of, let's say, 3.4 and a standard deviation of 2.4. All right? The mean exam score after the intervention was 5.46. All right? Very descriptive. Inferential statistics, all right, they infer properties about the population. So you can look at relationships between variables. You can look at differences between groups. You can also look at the structure and reliability of a scale. And I've given you an example here. When we make inferences, we're essentially making an hypothesis based on theory, literature, and even our experiences. We're predicting outcomes of the study. In statistics, we test the null hypothesis. In other words, we are to test to see that there's no difference or relationship between variables or groups. Now, there are standards we use to determine how well data support the null hypothesis. These you may have heard of before: p-values, which are the level of marginal significance within a statistical hypothesis test, representing the probability of the occurrence. I'll explain this in the next slide. Or even looking at effect sizes, which are becoming more common to report. When using p-values, we need to consider the probability threshold. Results lower than the threshold allow us to reject the null hypothesis and claim statistically significant effects. The smaller the threshold, the stricter the test. Generally, we set the threshold or significance level at 0.05. The p-value tells us how likely it is to get a result if the null hypothesis is true. If the probability is greater than the threshold, then we keep the null hypothesis. If it is less, we reject it. Okay, we have a question here, but what I think I'm going to do is I'm going to save this question to the end, all right, and then we'll address it because it has to do with factors outside of survey construction, all right, that we might want to talk about. So let's save that to the end. Hope that's okay. All right, p-values. All right, so again, to reiterate, a p-value is the probability of an observed result, assuming the null hypothesis is true. If the probability is greater than the threshold, we keep the null hypothesis. If it is less, we reject it. So, what kind of test will you use? If you're looking to explore relationships between variables, the green figures, then you have categorical or ordinal variables, you'd run what we call a chi-square table. If you have continuous, ratio, or interval data, you'd run correlations, bivariate correlations, for example, or multiple regression. If you're comparing means of groups, you can either conduct a z-test or t-test. Depending on the type of means you have, they can be paired or independent. And if you have a two-sample means or a one-sample t-test, if you only have a single sample. I'll give more detail in subsequent slides. Now, t-tests and multivariate statistics are sensitive, and they require that you meet a number of assumptions. In other words, that the assumptions about your data are true. And they generally have to do with the population distribution. Another name for the non-parametric test are distribution-free tests. All right. These non-parametric tests are ideal when you have categorical or ordinal or even ranked scales. The parametric tests on the left side of the scale, and then you can see on the right side of the slide are the non-parametric alternatives. So, for example, the Wilcoxon signed rank test is the alternative for a paired sample t-tests. Recall that these were the green figures on the flow chart 2 slides back. Correlational tests for relationships between variables. Often they're linear, it could be positive or have a negative relationship. For example, you may have feelings of enjoyment that are positively related to class performance. As enjoyment increases, performance increases. A bivariate Pearson correlation coefficient indicates that strength of the correlation, and it ranges from 1 to positive 1. From negative 1 to positive 1. Regression analysis, all right, models the relationship between the variables to determine which variables are significant predictors. Now, we commonly use this when there are 2 or more predictors. For example, prior experience and learning strategies are both significant predictors of performance. Next is a chi-square test. All right, this is sort of the third example. All right, so a chi-square test, all right, is when we're analyzing categorical data. You know, the things like yes, no, pass, fail, error, no error. Example, right? Students who attend a technical skills simulation had less surgical errors than those who did not attend. Now, recall the multicolored figures on the which test to use slide. The t-test. All right, the first is a pair samples t-test, or repeated measures. And this is used, all right, to measure 2 time points, like a pre-test and a post-test. Just a word of caution here. When you're doing this, to be able to match tests for individuals, you need to provide sort of a non-identifiable participant code. And there's a number of ways of doing this. For example, you could use the last 3 digits of the postal code or the date of your mother's birthday, etc. Independent samples, all right, was where you're comparing means of independent groups. All right, here's an example. Student concentration scores are higher for those in the intervention condition than in the control. Next, analysis of variance. All right. This is actually very similar to actually a regression model. And we use this when we're comparing two or more groups. All right. We can have a between subjects, all right, or repeated measures. With the repeated measures, we're comparing means at 3 or more time points. All right. They can be factorial or mixed. This allows us, for this is an example, okay, to examine complex effects by testing for interactions. So, the impact of a new technology based on teaching method on performance depends on the learner's prior knowledge of the subject. Okay, that's a lot of information in a very short time. In conclusion, when you are planning for assessment and evaluation, keep in mind these questions. What elements of your evaluation involve quantitative measures? What elements will involve qualitative? What are the questions you want to know answers to? What statistical analyses will you do for the quantitative elements? And finally, how are you going to report your results? As I mentioned earlier, there are many resources available for how to present your results in both text, tables, and in graphs. We feel strongly that evaluation is essential for program health and well-being. Even if you never get an evaluation funded, just planning for it can help sharpen your program. It's also vital for the IPECP field to have high-quality evaluations. So we hope you pursue this goal, and we hope that these webinar sessions in guide number 5 will make your job a little easier. So thank you for joining me today. Now, before we move to questions, and I can see we've already got a few questions already, all right, I'd like to invite you to a program evaluation short course, which is part of the Nexus Summit on July 29th. The course will be conducted by Connie Smits, Laura Collins, Barrett McCallick, and myself. Registration details can be found on the Nexus IPE website, and you can see I've put a link to the short course on the bottom of the slide. All right, and I hope to see you there. So now, let's move to some questions. All right.
Doug, what a great session. We have a few questions that have come in, so I'll share those with you. The first is, what other factors outside of survey item construction might affect the quality of data, such as data collected from records or observations? And also, are there things that can happen during the collection of data that might affect its quality?
Sure. I mean, that's a very good question. And actually, it can be very site-specific. So, for example, if you're looking at data from records, you want to look at how those records were collected, who collected them, how long ago were they. You need to think of what are some considerations for validity, for reliability. All right. Often when we look at evidence, the first evidence that we're looking for is what we call content evidence, right? So who puts things together? All right. Was it a group of experts that did? All right. So that's a very important consideration. Are there things that can happen during, just reading the second part of this question?
Yeah, that can happen during the collection of data that might affect its quality.
Sure, absolutely. Very often, for example, if you are doing paper surveys, all right, a source of error can be when the questions are copied from paper into a spreadsheet. All right, it's another advantage of using statistical surveyware, software that's available online, where this is done automatically, and it helps sort of reduce that human error. All right, so that's an example. All right, so human error is actually something that we want to try and mitigate as much as possible.
Great. Thank you. We have another question. Can you give some examples of a guiding evaluation question in IPE that is addressed with a quantitative method in its analysis?
Sure. Again, I think in some of the earlier slides, I got to this, right? We want to be looking for quantitative type questions. We're looking at the how questions, all right? So sometimes they may not necessarily start with how, it may be a what, right? So if we are looking at, for example, what is the difference between two groups, all right, when there is a certain intervention that's applied. Or we may see a question of, is there a certain factor that predicts a certain outcome? I mean, these are obvious quantitative type questions. Qualitative questions, of course, look much different, right? Where we're trying to understand why something happens. All right, so it may be leading, what are the perceptions that certain individuals have, or it may be why do individuals do the things that they do. All right, so the quantitative questions, it's more sort of the the what and the how. Great,
thank you. Here's another question that's come in. Is it ever okay to conduct both parametric and non-parametric tests of your data? For example, both a paired t-test and Wilcox signed rank on pre-post continuous data, if some variables appear to be normally distributed and others are not within a scale?
Yeah, it's somewhat of a subjective call, all right? Very often in interprofessional type activities, we don't get normally distributed data, all right? And sometimes it's skewed, all right? And we have to make that call whether we are going to use a parametric test or not, all right? And that's where I'd really get some consultation from a statistician, all right? To what extent are you willing to live with this violation of an assumption? To answer that, can you use both? To play it on the safe side, if I'm convinced that my data is normally distributed and I haven't violated that assumption as well as some others, I'd be very comfortable with using a parametric test. If I knew for sure that I had unequal groups or I was violating a number of assumptions, I would certainly do the non-parametric. I would certainly do the non-parametric alternative, which is that case for a t-test. The alternative would be the Wilcox signed rank test.
Wonderful. The questions keep coming. Here's another.
That's good.
Can you explain again what nominal, ordinal, interval, and ratio variables are, and give a few examples?
Yeah, sure. This is a good question. It's good to be able to note these because it's really important to understand what type of data that you are using. All right. So nominal, as I mentioned before, right? This is just data that we know that we can count, and it may simply be even categorical type data, right? Where we have, yes, no, where we may have marital status, being married, not married, that sort of thing. All right. Ordinal data, okay, this is when, and when we're starting to get into being able to see a sequence in the data. All right. So, for example, I would say like a Likert scale would be ordinal, right? Where we may strongly agree with something, we sort of have neutral, it's sort of ordinal. Interval data, this is where the intervals are actually very important. So, for example, temperature, all right? So certain medication can only be given, at a certain temperature range, all right? So that could be considered interval, all right? And then ratios, I think that's pretty straightforward, right? Where we're looking at, 2-to-1 type ratios, 3-to-1 type ratios, that sort of thing. So that's sort of the difference. And depending on what type of data you have will, in turn, affect what statistical analyses you can do. So, for example, if you're using Likert scales, all right, I wouldn't do any more sophisticated tests on that data other than descriptive. And the reason for that, and this is kind of a misconception, is that people treat the Likert type scale questions as interval data. All right, and the problem with that is you're making this assumption that if you strongly agree with something, it's at the same distance as something that you agree with. All right, but if you think about it, if you strongly agree with something or you strongly disagree with something, that's a much larger interval than if you are sort of neutral, or you agree, or you're neutral and you disagree about something. All right, so if it's interval data or continuous data, then certainly continuous data, for example, like marks on an exam, okay, then you can certainly do some inferential statistics. If you just have nominal data, all right, then you are more restricted to using more descriptive type data.
Great, thank you. All right, one more question. What are some common pitfalls with doing the analysis of pre-post data? What does retrospective pre-post analysis mean? And when or why would you want to make that choice?
Yeah, that's a good question. For example, a test that I was involved in designing, we actually did a retrospective pre-test, post-test type of analysis. And what that meant is that when you do a retrospective pre-test, post-test, the learner receives this test at the end of the intervention, and they think back to how they perceive certain questions before the intervention. All right, and the reason why retrospective pre-test, post-test can be used is that often in interprofessional education, learners are often early adopters. So on a pre-test, they tend to rank themselves very highly. And then when it comes to the post-intervention, they still rank themselves highly, and there's not much of a difference. So then when you do any comparative analyses, you don't see any changes. Whereas if you use the retrospective pre-test, post-test option, there's probably a higher likelihood that you're going to see some variation in the results.
Great. Thank you, Doug. We'll just check in here for a minute. We're at the end of the great questions that have come in over the course of the webinar, so we'll just give people a second if there's anything else that they would like to type in. It doesn't appear there's any activity happening. So I think with that, we will close out this webinar. Thank you so much, Doug, for sharing with us today, and thank you for everyone that logged in to learn more, and we'll look forward to seeing you again soon.
Thank you very much, everyone.